All right, let's talk through some of the things we saw. So when we're reversing C++ programs, simple classes would look just like C structures. You would see them simply on the local variable stack as we did, but we were able to also find the vtable because we knew a little something about it. Also, we saw that the weird mangling names could often be corrected in IDA, and that was something that was easy for us to deal with there. And as we look through C++ objects, especially ones where there's a new associated with it, we'll be able to follow those with the use of ECX typically. And we didn't have to do that in this case because of the local construction, but that's often quite helpful, and it's the first argument passed to every routine in G++, so that also gives us better insight that we're reversing C++ and tells us something about the object at hand. So one of the biggest hints we can get about the size of an object is either by looking at the local variable stack, or when we see a new to allocate space for an object, that'll give us the size of the object, and that'll tell us something about the number of fields and whatnot. We may also see things like a superclass constructor, which could reveal hierarchy, and then we'll typically see a copy of a vtable address into the vpointer table field. And just like we saw with the variable a for our class, we'll see some class members get initialized as well typically. You may remember something about object-oriented programming if you ever took programming in a computer science curriculum, and there was a word called polymorphism you might remember being used, and what that provides is the same name for a function in a different object to provide different functionality. And if you ever wondered, how does that really work? Well, it's just a table of function pointers, and you get one entry per virtual function, and oftentimes if there's an error function called a pure virtual slot, you'll see that as well if there's an abstract superclass. But basically, you just get a list of function pointers, and that's one of the reasons why, from a security perspective, with C++ programs, there is sort of ample opportunity, unless there's modern protections in play, for an attacker to be able to corrupt one of those function pointers and point it to malicious code. So that's something that when we get to the exploitation section, we'll talk a little bit about that. So for now, we'll see some slight differences in how different compilers like GCC and Visual Studio implement all of this functionality. But the first member of a class is basically a pointer to this vtable. What we typically have is a pointer to our class, and inside that we have any member variables, and then we have a pointer to our code, our vtable pointer, which points to the various methods within the class. And it's pretty much that simple. And when you derive from a parent class, you get those members plus any new members, and you're able to redirect any methods to new code as needed. Object destruction is the reverse of creation. We'll restore a vtable pointer in case a subclass replaced it during construction. We'll perform any code-specific local destruction tasks. If any data members are objects, we'll call their destructors, which frees the memory, and finally we'll call the superclass destructor as needed. So what's the point of the runtime type identification, the RTTI, that I was telling you about? It's for type ID in dynamic cast. It's utilized only for objects with virtual methods. So if type ID isn't used, RTTI information could actually be stripped out of the binary to make it a little more secure, although typically I don't see that done a whole lot. So the pointer to RTTI, just like we saw, precedes the vtable pointer. And the structure makeup varies among compilers, and I'll show you a couple here. They all include information about the original class name and superclasses. Here's a Visual Studio RTTI diagram. Here we have a class with a vtable pointer and a member A, and we point to the first function here, and one function above that is the RTTI pointer, which points to a number of different properties, the signature, offset, all of these different things that you don't need to know a whole lot about for now, but the type description actually points to the area where the original class name is stored. The G++ structure is even simpler. We have a vtable pointer, and above that we have a pointer to our RTTI structure, and in there is a pointer to the class name. So what we saw in our example was that discovering member functions, the easiest way to do that was by finding the vtables and following the pointers. For non-static members, recognizing the this pointer is very helpful, and it could be something other than ECX in different compilers. For static member functions, without this and without the vtable, that could be a little bit trickier. You'll just have to identify the code in whatever way you normally do. In summary, we talked about C++ reversing and used an example to describe how classes and members can be found. We also used the runtime type identifier to discover the original class name. Next, we'll finish this class by learning how to extend IDA Pro.